in the arithmetic section, we're going to focus on adding, subtracting, multiplying, and dividing fractions, decimals, converting to percents to decimals, um, looking at some word problems. So in this section, we're not going to be using a calculator because we really want to make sure that you know how to do these operations by hand and not using a calculator. So let's go through this test A and just kind of look at some of the different types of questions that you could see. So the first one here, we're adding decimals. Whenever you add decimals, you want to line up the decimal points. So that's the first thing. So I'm just lining up the decimals, and you can put zeros in the other places, but you really don't need to. And then you're just going to add vertically. So I go down, I have 3 here. Then in this position, I have 7, 5 plus 2. And then in this one, I have 4 plus 1 plus 6. So 4 and 6 gives me 10, plus 1 gives me 11. Carry the 1. I'm going to carry down the decimal place. And then I have 3 plus 1 plus 1, so I get 5. And then I have 5 in the other section. So my answer for this one is 55.173. So looking at choice B, we want to reduce this fraction. So whenever you're trying to reduce a fraction, you want to look for a number that goes into both the numerator and the denominator. So right away when I do this, I think of the number 7 as going in the top and into the bottom. So I'm going to go ahead, I'm going to divide the top and bottom by 7. So I end up with 4 over 6 when I do that. 28 divided by 7 is 4, 42 divided by 7 is 6. So I can do this because I divided the top and the bottom by the same thing. And then in this case, when I get 4 over 6, I still recognize that both of those are even numbers. So that means I could take a 2 out of both of those. So then I'm going to simplify it further and take out a 2. So I have 2 on top, and when I divide 6 by 2, I get 3. So the fully reduced version is 2/3. Now, some of you might have saw right in the beginning here that you could have taken out a 14 from the top and bottom, and you would have gotten right to 2/3. But if you don't see it, you just take out whatever you can from top and bottom, and then you just keep reducing until you can't reduce any further. The next one here, we want to convert 0.3% as a decimal. So whenever you want to convert something to a decimal, that means you're going to move the decimal places 2 places to the left, because essentially what you're doing is you're dividing by 100. So 2 places to the left gives me 0.003. So choice B. Since I'm dividing by 100, 2 places to the left is where you move the decimal. The next one here, we're adding fractions. So in order to be able to add fractions, you got to get a common denominator. So the least common multiple is going to be your common denominator. So the least common multiple between 8 and 5 is going to be 40. So that means I'm going to take this fraction, or these fractions here, and the first thing I'm going to do is rewrite them so that they have denominators of 40. So what you have to do is you have to ask yourself, how did I go from 8 to 40? Well, I multiplied by 5, so that means I have to do that on top. So I get 15. And then over on this side, you ask yourself, how did I go from 5 to 40? Well, we multiplied by 8, so you have to do that on top. So 2 times 8 gives me 16. So then when you go to add these fractions, you keep the denominator, and you actually go through and add the numerators. So when you do that, we have 15 plus 16 is going to give me 31, and then you keep the denominator as 40. So choice D for that one. So then looking at the next page, we want to estimate the product of 5.95 times 59.7, because it's saying it's slightly less than. So the fact that it uses the word slightly tells me that they're estimating. So instead of using 5.95, let's think of that as 6. And then instead of using 59.7, let's just round that up to 60. So approximately what we're doing is 6 times 60. So if you just multiply the 6 and the 6, you get 36, and then carry the zero. That's kind of like the rule, the shortcut for when you multiply when you have zeros. But if you formally multiply, you would set it up 60 times 6, and you would go through 6 times 0 is 0, 6 times 6 is 36. So that's just another way of doing it. So regardless, you get 360. For the next one here, we're dividing. So remember, dividing by 3 is like dividing by 3 over 1. So the rules for this are keep, change, flip whenever you are dividing fractions. So you're going to keep the first one, change the sign to multiplication, and then you flip the second one. So flipping the second one is going to become 1 over 3. And then when we multiply fractions, we multiply across the top. So 3 times 1 gives me 3. And then we multiply across the bottom. 5 times 3 gives me 15. And then I want to reduce this if possible. So if you look in the top and the bottom, you could take out a 3. You could divide the top and bottom by 3. So when I do that, I get 1 up top and 5 down below. So my final answer is going to be 1/5. Number 7, we're trying to find 14% of 14. So whenever you're trying to find percent of something, this means to multiply. So you're trying to find 14% times the 14 because it's of 14. So to do this, you have to move this decimal, or the decimal place that's over here, you have to move it 2 places to the left because we want to turn it into a decimal. So the decimal for the number 14 is really right here. So I'm going to move that decimal 2 places to the left. So it's going to be 0.14 times 14. So I'm going to do that off to the side. So 0.14 times 14. So we multiply everything by 4 first. So we get 16. Carry the 1. 4 times 1 is 4 plus 1. It's going to give me the 5. Move over a place. So I just put an X here in this position. 1 times 4 is 4. 1 times 1 is 1. Then you're going to add your results. So we have 6, 9, and 1. And then since I had 2 decimal places here, that tells me that I have to move this 2 decimal places. So my answer is going to be 1.96. So 14% of 14 is 1.96. This next one's kind of a thinking question. So it's talking about an 80-foot board is being cut into the ratio of 2 to 3. So into a 2 to 3 ratio means that there's going to be 5 parts. So basically, just to kind of help you visualize this, so we have this board that's going to be broke up into a 2 to 1 to 3 ratio. So 2 parts to 3 parts. And then the whole entire thing is 80. So basically what you want to do is you want to figure out what one of these sections is. So if we know that the whole thing is 80, if I can figure out one of these sections, then I can just add it 3 times or multiply it by 3 to get the length of this section here, the longer piece. So what we first have to do is we have to figure out what each part is. So since there's 5 total parts, since it's a 2 to 3 ratio, that means what I should do first is divide 80 by 5. So I'm going to do that. So 80 divided by 5, 5 goes into 8 one time. 5 times 1 is 5, so we carry that down, so we get 3. Bring the 0 down. So 5 goes into 36 times. 6 times 5 is 30, so I don't have a remainder. So that means each one of these is 16. So if you want to find the length of the longer piece, well, that means you have to add these up. So 16 plus 16 plus 16. So 16 plus 16 is 32. Plus another 16 is going to be 48. So essentially what I did was 16 times 3. So 6 times 3 is 8. Carry the 1. 3 times 1 is 3. Add 1, you get 4. So that whole thing is going to be 48. since it's asking for the longer piece. If it was asking for the shorter piece, I would be using this section here. The next question here is saying that 3/8 as a decimal to the nearest hundredth is, so that tells me that I have to actually get this as a decimal. So I'm taking 3/8 and I'm making it a decimal. So instead of thinking of it as 3/8, I'm really going to think of it as 3 divided by 8. So it's going to be 3 divided by 8. And in order to do this, you need to be able to add some numbers here because 8 doesn't go into 3. So the decimal place is right here because 3 is a whole number. So I can just carry the decimal up top. And then I can add as many zeros as I need to after it. So then what I'm looking at is 8 going into 30. So I ignore the decimal place here. I just put it there because it actually will be in my final answer. But at this stage, I can kind of just ignore the fact that there's a decimal there. So I ask myself, 8 goes into 30 how many times? Well, the answer to that would be 3, because 3 times 8 is 24. So then there's 6 left over. And then you can just add another 0 at the end, because it's just 3.000. You can have as many zeros as you want. So then you carry down the 0. And then you ask yourself, how many times does 8 go into 60? Well, it goes into 67 times. So 7 times 8 is 56. Subtract your 4. Add a 0 at the end. Carry it down. 8 goes into 45 times. 5 times 8 is 40. So that means I'm done. I don't have a remainder. I can stop there. And it says to the nearest hundredth. Well, I always think of hundredth as 100 has 2 zeros. So that means I'm going to be rounding my answer 2 decimal places. So 0.375 would round up to 0.38 because the 5 is going to bump the 7 up. So choice D would be your answer for this one. Looking at the next one here is a conversion problem. So not something that we've really done a lot with, but just kind of a problem that you could see on an AccuPlacer exam is where this is coming from. So if we have 3 yards, 4 feet, and 5 inches, and we want to convert everything into inches. So that means I want to think about my conversion. So the first thing, if I want to take 3 yards and convert it into inches, I have to know what's the relationship here. So the other thing is with feet. So how am I going to convert feet? So the first thing I'm going to do is I'm going to take the yards and turn them into feet. So I know that 1 yard is the same thing as 3 feet. So what I'm going to do is I'm going to set up a proportion that uses this. So this is the conversion, 1 yard equals 3 feet. And then according to my problem, I have 3 yards. And I'm trying to figure out how many feet. So that's going to be my x. Notice that on the top I have the same units, and then on the bottom I have the same units. That's how I knew to put the 3 yards on top. So then from here I can cross multiply, so I get x equals 3 times 3 is 9. And my units on this are going to be whatever I'm solving for. So in this case I was solving for x, so my units are going to be feet. So that means instead of saying 3 yards, I could really say 9 feet. So total, 9 feet and 4 feet gives me 13 feet. So the next thing I want to do is I want to get this all over to inches, because if I know what 13 feet is in inches, then I can just add the 5 inches to it, and then I'll know my total inches. So the next thing is looking at the conversion between inches and feet. So 1 foot is equal to 12 inches. So if I want to set up a proportion to be able to figure this out, if you think about it in terms of your feet have to go on top and the inches have to go on the bottom to match your units here. Well, we have the feet is 13. We're trying to find the inches, so I'm just going to put a y there. That's my unknown. Cross multiply it, and we just have to solve that. So y is going to equal 13 times 12. So 13 times 12, multiply 2 times 3, you get 6. 2 times 1, you get 2. Move the placeholder. So we have 1 times 3 is 3, 1 times 1 is 1, And then you add these, so we get 6, 5, and 1. So 156 inches. So then I know that this 13 feet is equal to 156 inches. So if I want to know my total inches, I would have to take my 156 plus this 5 inches here. So 156 inches from the first two numbers plus the 5 inches. So when you add those up, you get 161 inches. So with these, you don't have to show these proportions. I just show the proportions so that if you're not sure, do I multiply by 3 or do I divide by 3? What's the rule? If you set up the proportions, they always work as long as you make sure that your units on top match and then your units across the bottom match. And then you just set up your proportion, cross multiply, and solve. But you don't have to do it that way. It's just if you get confused on whether to multiply or to divide. Number 11 here, we have 3 workers that are doing a job. The first one does 1/3 of it, the second one does 1/4 of it. In order to finish the job, what part must the third worker do? So far we have 1/3 of the job plus another fourth of it is already done. So let's figure out what this actually equals. So first thing you got to do when you're adding fractions is get a common denominator. So 12 is the LCM here, the smallest number that both 3 and 4 go into. So then what I have to do is I have to say, okay, well, what did I have to do to 3 to get to this common denominator? I had to multiply it by 4. So you do that on top and bottom. This one you had to multiply by 3 to get to 12, so do that on top and bottom. And then you're going to keep the denominator, which is 12, and then you're going to add on top 4 plus 3, so we get 7 over 12. So that means I have 7 over 12ths of the work done total. So if you think about that, how much would be left? Well, how much more do I need to get 12 over 12? So the answer is you need 5/12 more. So essentially what I'm doing is saying, okay, well 12 over 12 would be everything. That would mean it's complete. I already have 7 over 12. So if I subtract that, that tells me that I have 5/12 left for the third worker to do. The next one here, remember what we said, 9% of some number is 18. So 9% of what is 18? So remember, of means multiply. So what this is essentially saying, our what, let's just call it an x. So 9% of x is 18, which really means 9% times x is equal to 18. So remember, when you convert the 9% to a decimal, you're going to move the decimal 2 places to the left. The decimal starts here, and it's going to get moved over to here. So it's going to be 0.09 times x equals 18. That's what I'm trying to solve. So 9% of what number equals 18? So to get x by itself, you're going to divide both sides by 0.09. So then by hand, to divide this, since you have a decimal over here, you move this over now to the right so that you're just dividing by a whole number, not a decimal. And the decimal of 18 starts on the right side of 18, but since I moved the division over, the decimal over 2 places to the right, that tells me I have to move this decimal 2 places to the right. So that means I add 2 zeros. And now I just do my division as normal. So it's really what I'm looking at is 1800 divided by 9. I don't really care about that 0 anymore. So when I go ahead to do this, I ask myself, how many times does 9 go into 1? Well, it doesn't. So I ask myself, how many times does 9 go into 18? It goes into 18 2 times. So when you multiply these, you get 18. 2 times 9 gives me 18. Subtract, you get 0, and bring down the zeros. How many times does 2 go into 0? Well, 0 times. 0 times 9 is 0. And you carry down this other 0. How many times does 9 go into 0? It goes into 0 0 times. So my answer here is going to be 200 because, again, remember you could carry this decimal point up, so it's 200. So if I take 9% of 200, I should get out 18. That's what this is saying. The next one here, we have a mixed number times a mixed number. So the first thing I would do is convert these to improper fractions, because once they're improper fractions, you just multiply across the top and then you multiply across the bottom. So in order to convert this, what you do is you take this number and you're going to multiply it by 1, and then you're going to add whatever you get to 3. So the denominator is going to say 4. So 4 times 1 is 4, plus 3 gives me 7. So that's going to be the first one. This is the exact same thing. So 4 times 1 is 4, plus 3 is 7, and you're going to keep the 4 on the bottom. And then whenever you multiply across the top, and then you multiply across the bottom. So now if you look, I get an improper fraction, but all of my answers are mixed numbers. So to convert this back to a mixed number, you have to figure out, well, how many groups of 16 go into 49? So 2 groups would be 32, so I can actually fit 3 groups of 16. So there's going to be 3 groups of 16, and then the question is how many is left over. So if I do 16 times 3, I get 48. So when I do 49 minus 48, so if I put 3 groups of 16, there's 48 with a remainder of 1. So I'm left with 1 over 16. So 3 groups of 16 go into 49 with 1 left over. So 1 over 16 is left over because I divided by 16. Alright, so the last few here, this one we're dividing, so we're doing 0.03 divided by, or 42 divided by 0.03. So we're going to go ahead and we're going to, again, because we're dividing by a decimal, we move the decimal 2 places to the right over here. This decimal place starts after the 42, so I have to move this decimal 2 places to the right as well. So remember, your decimal place is now up here. So then you're just doing 3 going into 4200. So 4200 divided by 3 is essentially what the problem becomes. So how many times does 3 go into 4? Well, it goes into it 1 time. So 1 times 3, carry that down. Carry the 2 down. So how many times does 3 go into 12? Goes into it 4 times. 4 times 3 is 12. And then you carry down the 0. How many times does 3 go into 0? 0 times. 0 times 3 is 0. Carry down the 0. How many times does 3 go into 0? 0 times. And now I can stop because I've gotten to the decimal point, so I've filled in every position on the left of the decimal. On the right of the decimal, I don't need to keep doing because it's just going to be 0.0000. So my answer to this question would be 1400. For this one, we're going to be subtracting. So again, I would convert this over to an improper fraction so that it's consistent. So I'm going to have 4 over 1 is my fraction here, minus, so remember, you multiply and then you add. So 5 times 1 is 5. 5 plus 3 is 8. So it's going to be 8 over whatever the denominator was. So remember, in order to be able to subtract, you got to have common denominators, which in this case are going to be 5. So what did I do to 4 to get to 5? Well, I multiplied it by 5, so that means I got to do that on top as well. And then the 8 over 5 is just going to stay as is. When we go to subtract, we're going to keep the 5. We're going to subtract these, so we get 12. So there's my improper fraction, and then again, to turn it into a mixed number, you have to ask yourself, well, you actually divide these, 12 divided by 5. So how many groups of 5 are going to go into 12? Well, there's 2 groups, because 5 times 2 is 10. And if you think about it, what's the difference between 12 and 10? is 2, so there's 2/5 left over. So you can fit 2 groups of 5 in here with 2/5 left over. So 2/5. All right. Next one here, we have a high school basketball team made 70% of its free throws. If the team made 280 free throws, so they made 280, how many free throws did he take? So they're saying that out of the total number of free throws he made 280 of them, which happens to be 70%. So the question is, how many free throws did he take, or how many free throws did we actually perform? So that's going to be my x, or my unknown, and we're saying that 70% of x, so times x, is equal to the total number of throws that they actually made. So is equal to 280. So that really means if you move the decimal 2 places, 0.70 x equals 280. So divide both sides by 0.7, and that'll tell us what x is. So we're going to have 0.7 outside, so 280 divided by 0.7. So again, moving the decimal over. So you could look at this as 28,000 divided by 70. Another way that you could think of this, though, if you don't want to deal with as big of numbers, is if you just say, okay, well, I'm going to drop this 0. So instead of saying 0.70, I could just say 0.7. So I could just say 280 divided by 0.7. So that's a little bit easier because then you're not dealing with 70. Because here when I move the decimal over, now I'm dealing with 70 as what I need to figure out if that number goes into the others. So I'm going to use this one because it's going to be a little bit easier. So I'm going to move this over one place, which tells me I have to move this one place over. So now I'm just looking at how many times does 7 go into these. So how many times does 7 go into 2? It doesn't. So how many times does 7 go into 28? Well, that's 4 times. So 4 times 7 gives me 28. Carry down the 0. 7 goes into 0 0 times. 0 times 7 is 0. Carry down the 0. So I carry this 0 down. 7 goes into 0 0 times. 0 times 7 is 0. So we're left with 400 as an answer. And that would be the same answer over here. It's just, again, like I said, then you're dealing with 70. So instead of thinking of it as 7 going into 28, you'd be thinking of it as 70 going into 2800 or 280, which would happen 4 times. So, and then you would have your zeros at the end, so you get the same answer. It's just bigger numbers. So then the next and last one here is how many hours are there in a week? So this is again kind of like a units thing. So the number of hours in a week. So there's 24 hours in one day times 7 days per week. So you just have to multiply those. 24 times 7. So 7 times 4 is 28. 7 times 2 is 14. 15, 16. So 168 hours. So that's it for this test. Like you've seen, there's a mix of problems. So the next thing you want to start working on is test B, to just see some other types of these arithmetic type problems.